The steelhead appliance is deployed as a two-port bridge in most cases. Typically, the appliance will sit between the LAN switch and the WAN router. So we're going to sit in line. We also have out of path or logically in path options we'll talk about later. We will pass through traffic automatically with very low delay that we can't help. So that's going to be things like encrypted traffic, UDP traffic, Citrix voice, anything small and interactive like Telnet, RDP, those kinds of things. All of the appliances have fail-to-wire NICs, so that if there's a hardware error or if you lose power to the appliance, we'll automatically pass traffic through. Traffic can be configured for optimization or pass-through using in-path rules, and that can be based on the port number or the source or destination IP address. So if there's traffic that you don't want to optimize, you can pass that through with a simple rule. This works really well for troubleshooting. The steelhead appliance needs two IP addresses. First, it is required IP address for the in-path interface. So remember, this is a two-port bridge, so the IP address for the in-path interface sits logically between the LAN and the WAN ports. The second IP address is for the primary port, and this is used for management. It's not required, but it's highly recommended. In order to properly size a steelhead deployment, there's a couple of things you need to think about. First is the number of connections. So each steelhead model has in their specifications a WAN optimization limit, a speed, and the number of connections that it supports. So let's take an example. The 250L is the smallest steelhead appliance that you can buy. It has 1 megabit per second and has 30 connections. So we use 5-to-1 as a rule of thumb, so 5 connections per user. So a 30 connection device would support up to 6 people, so for a very small office. So for the specifications for all the steelhead models, just divide the connection count by 5 and you get the number of users that would be supported at that site. As far as bandwidth, the steelhead WAN specification, again, if we take the 250L, is a 1 megabit per second box. So that's optimized output. All right, so that's optimized output of that appliance. So that means that for outbound traffic, we can only optimize onto the line 1 megabit per second. Now you could still use that steelhead on a T1 line because you have 1.5 megabits per second. The optimized traffic will only take up 1 meg per second, but then anything that we don't optimize will ride above that. So things like voice, video, UDP traffic, encrypted traffic that we don't optimize will fill up the rest of the pipe. So the WAN does not have to exactly match the specifications of the steelhead. It should be close though. Disk size you really have no control over. Each steelhead model has a certain size disk for the data store, but it does become important if you're doing backup and replication, and we'll talk about that here in a minute. The other thing is you might need RAID or redundant power supplies, and those features are not available in the desktop units. So that might push you up into the one rack unit models. And the last thing to consider is port availability. The desktop models only have 2 ports, one LAN, one WAN, so they can sit on a single segment at a time. The 1U models have up to 8 ports total, so they can sit on 4 Ethernet segments at the same time, and the 3U models can sit on up to 10 segments at the same time, so 20 ports total. And so the reason you might do that is, let's say you have a site that has a primary connection out to a router that's connected to an MPLS network, and then your backup connection is some slower speed technology like DSL or cable modem or something. And in that case, you'd want to sit on two different segments so that if the MPLS cloud dies and routing kicks it over to the backup connection, we can still optimize that traffic. So as far as redundancy, a little more information here. The 1050 has dual power supplies as an option, so it comes with a single power supply. You have to buy a second one if you want it. The 2050 has RAID and dual power supplies as a standard feature, so it's not an extra extra feature. It comes standard with the 2050. And then the 3U models, so the 5050 and the 6050, have dual power supplies and RAID automatically built in. If it's a very critical application and you really need 24 by 7 by 365, so no downtime, you can put in multiple steel heads and you can do them either in a serial cluster or in a parallel cluster, and you can do them where they're active active, active passive, and also you can use data store synchronization to make sure the patterns are copied between the two boxes that are in the cluster. And of course, you can always have an offline cold standby, just another steelhead sitting there waiting for the other one to fail. In planning a steelhead deployment, there's a few things you need to think about. First of all is the overall architecture. Most customers are fine with putting an appliance inline at a remote site. But in the data center, sometimes they're not, and that's for a variety of reasons. Typically, it's because they don't trust or fail to wire. They don't like the idea of another appliance inline that's a failure point, things like that. So your choices in the data center are in-path. You can do WCCP or policy-based routing, or a strict out-of-path, which we'll talk about these scenarios later. The next thing again would be redundancy. Do you want to do a parallel cluster, serial cluster? And we'll talk about that in detail coming up. And then you need to do the same thing at the remote sites. Once you've got that figured out, you need to size each location with the metrics we talked about on the last slide. Collect the shipping and timing information. Make sure that you know who's doing the installation. Are you going to use our CMC and do a touchless configuration? Or are you going to have some technician at the site be able to install the product? If it's a tricky network integration, things typically that would be layer 4 redirection, policy-based routing, or WCCP, then collect all the information about the routers, iOS versions, and check with your local Riverbed SE or our support department, because those deployments can get tricky. There's a lot of bugs in iOS and different versions of software, and there's hardware limitations, and all those things need to be considered. Here is the current Riverbed product line. If we start over on the left side, you see we start with the desktop units. So the desktop units are smaller than a 19-inch rack mount product, but they do come with the ears so that you can rack mount them if you so desire. But they can also sit on a table or on a shelf in a computer room. The next column is the 1 rack unit models, and the next column is the 3 rack unit models. And as you can see, as we go from the desktop units to the very large units, the 3 units, we get more and more connections and more speed on the WAN connections. So whereas the desktop units go from 1 meg to 2 meg and from 30 optimized connections to 600, the 1U are in the 6 megabit per second range up to 45 megabits and up to 6,000 optimized TCP connections. And then the 6050 is our largest single device at 50,000 connections and 310 megabits per second. You also see the interceptor, which is our layer 4 load balancer. So for very large scale data center deployments, you can use it to redirect traffic to a farm of steelheads, get up to 1 million TCP connections. And then you also see the central management console and Steelhead Mobile. As far as upgradability, each series is upgradable within the series. So for example, you can upgrade a 250L to a 250M to a 250H, so from low, medium to high, just with a license upgrade. Same with the 550M to the 550H. Now certain upgrades will require a hardware upgrade. So for instance, if you bought a 1050L today, you could upgrade it with a license key to a 1050M, but if you wanted to go to a 1050H, you would have to add some memory and another hard drive. So certain models require hardware also, and that's part of the kit you get when you buy the upgrade. Here you can see some more details about the hardware. First of all, we'll start with some older hardware we have that you'll still run into in the field. In the desktop sizes from 50 up through the 300, and in the 1U sizes, the 520 through the 2020. These products are not shipped anymore, but you'll run into them in the field. As you can see from the picture of the back of the 1U unit, you have the primary port and auxiliary port in the middle, and then off to the right there's one slot where you can have, in this case it's a 2-port copper. Options available there would be a 2-port, 4-port, or 6-port copper, and also a 2-port or 4-port fiber interface. So that's your actual LAN and WAN port for the inline installation. In the middle you see the 3020 through the 6020. It's their 3U hardware. You can see the front view shows you the different drive slots. This is a RAID box. And then on the right side there you see the back of the unit. So you'll see on the left side of that 3 power supplies, triple power supplies. That is automatically comes. That's not an option. Then you'll see in the middle underneath the fans you'll see a VGA port, a keyboard port, and so forth, but also the primary and auxiliary ports. And then to the right side of that chassis you'll see slots for the bypass cards. So again, same options as the 1U. You can have a 2-4 or 6-port copper or a 2 or 4-port fiber interfaces in there. You can have up to 16 ports total in this chassis. And then down below you see the actual boards, the actual cards that you can plug in. Here you can see more details on the new hardware. So the 50 series, the 250 and 550 and the desktop size models, and the 1050 and 2050 in the 1 rack unit sized models. So the 1050 and 2050, down below you see a rear view of that hardware platform. The 1050 comes with just a single power supply, and you can buy a second one as an option. The 2050 comes with both power supplies standard. You see in the middle there's a primary and auxiliary port and a console port. You also see over on the right side there's 4 ports built onto the motherboard. So whereas the old hardware you had to buy bypass cards to get any WAN or LAN ports, here you have 4 ports built in, 4 copper 10100, 1000 ports built in. You also see an expansion slot where you can add either 4 more ports of copper, or you can add the fiber options, 2 or 4 port fiber. So you can get to 8 ports total on this platform with the expansion card. Here's a picture of the new 3U hardware, the 5050 and the 6050. So as you can see on the back, if we start on the left side, you see the 2 power supplies. That's a standard option with both the 5050 and the 6050. You get the remote monitoring port, which is not live today, but it allows you to manage the box even if the operating system is not start up. Again, that's going to be turned on in a firmware version later. You get a console port, you get a USB ports, you get the LAN and WAN ports, so you get 2 LAN and 2 WAN ports built onto the motherboard of this product. And then you also get the primary and auxiliary ports for doing management. And then there's 5 slots, but only 4 are available for adding more in-path cards. So you can add a 4-port copper card, so you could end up with 16 ports there, 4 on the motherboard, so 20 ports total. So that means we could sit on 10 segments. You can also put either a 2 or a 4-port fiber card into those slots. So if you need fiber interfaces, we can accommodate that also. Let's go over some sizing guidelines for the branch and data center. First of all, let's assume that this is a WAN optimization opportunity without any data backup or replication. We'll talk about that in greater detail over the next few slides. So the first thing we would do is take all of the branch offices and size each one appropriately. So for each branch we need to know the size of the WAN pipe going in and out, and we need to know the number of WAN users in that location. So the customer should be able to give you both of those things for all of the sites that you're trying to size. So next you're going to do a calculation. So let's say that one branch office has 100 users and one branch office has 50 users. So multiply that by 5 and you'll see that you need 250 connections at one location and you need 500 connections at the other location. Next, you're going to move to the data center. You're going to add up all those remote sites and make sure that you have a data center steelhead that's big enough to cover all of that. So in this case, we have 750 total connections that we need to cover in the data center. Let's go over a steelhead sizing example. So here is a customer that has a primary data center with an 8 megabit per second connection. They have 3 branch offices. Branch A is a 4 megabit per second connection with 150 WAN users. Branch B is 2 megabits per second with 100 WAN users. And branch C is 1.5 megabits per second with 50 WAN users. So the first thing we would do is do some calculations to get our connection counts. So 150 times 5 connections per user gives us 750 connections we're going to need at site A, 500 connections at site B, and 250 connections at site C. If we add all those up, we get 1,500 connections that we're going to need to support in the data center. So if you go back to the slide with all the models and the specifications, you can easily see that the 1050L would be the right choice for branch office A. That's going to give us 800 connections and 6 megabits per second. The site B is going to need 550H, 600 connections and 2 megabits per second. The site C is going to need 550M with 300 connections and 2 megabits per second. And then in the data center, we're going to put a 1050H with 2300 connections and 10 megabits per second. Now, some things you might want to think about in the data center would be, first of all, do you want to do 2 1050s in a redundant pair like is shown in the diagram? Or you might want to add a second power supply. Remember that the 1050 series comes with a single power supply. If you want dual power supplies, you have to add that as an option. And then finally, you might want to think about the CMC, the Central Management Console. You could put a CMC into the data center, and now you could do code upgrades to all your boxes with a single click. You could push out configurations from a single management spot, and you can also aggregate all the statistics from the steelheads back into a single reporting structure. Now let's talk about a backup or replication scenario using steelheads. First of all, you need to consider how the data store is being utilized in the steelhead appliance. As we talked about before, the way our SDR technology works is we look for patterns in files, we write those patterns onto the hard drive of the steelhead, and we place a 16-byte label to represent that. And then we just send the labels back and forth after we've learned the data. When we store those patterns, there could be the same pattern existing in multiple different files. So we will leverage that. We won't store the same pattern more than once. So that means you get some amount of data reduction from the amount of data going through the steelhead to the amount of data that actually gets stored onto the steelhead hard drives. How much reduction is not an exact science. It really depends on the data. But this chart at the bottom will give you some guidelines there. If the images are very compressed already, you may only get 2 to 1. If it's log files, text files, things that are highly compressible, you could get as high as 5 to 1. So it really depends on how much duplication is in the data and what type of data. I personally like to use 4 to 1 as a rule of thumb. So let's go through a scenario here. First, what you would do is you would ask the customer, how much data are you replicating per day? So in this case, they're telling us 15 gigabytes per day. So that means if you use 5 to 1 as the best case, you're going to only use 3 gigabytes of steelhead storage per day. And so if you do the math on a 100 gigabyte data store in the 1050L here, you see that takes about 33 days or about 4 weeks to fill up the data store. If you use 3 to 1, it's 5 gigabytes per day, and it's going to be about 3 weeks before we fill up the data store. As a rule of thumb, we'd like to see at least 2 weeks before we fill up the data store. So that's the first thing you would do is you would say, okay, it's a 6 megabit link, so I'm going to pick a 1050L, which is a 6 megabit per second box. Then you do the calculations and you say, okay, the data store seems to fit correctly. If it doesn't, that might push you up to a higher model. If, say, we're filling up the data store in 4 or 5 days, then you would want to increase the steelhead model size to get a bigger data store so that it fits in the scenario. Now this is just for backup and replication where it's very, let's say medium to slow speed links. If you're doing high speed replication, high speed links in, let's say, the 10, 20, all the way up to a DS3 or higher speed pipes, then you need to take into account a whole other set of things like how are the disks going to react to being able to write at that high speed, and there's a lot of tuning you can do in the steelhead for those kinds of scenarios. If you do run into those types of scenarios, you're best off talking to our support guys or the field SEs in your area to help you size and configure that opportunity.